So this is the RHEL8 installer from ISO, and I'm starting without a kickstart file so that we have to actually step through the graphical interface to show you the features that we're activating. I'm sure that there's a way to do this from the kickstart file itself. I don't know what that is right offhand, but we're going to take a look at the features to enable CIS benchmark compliance from the start on install. And I apologize for the double mouse cursor. It's part of the way that I'm accessing the virtual machine. So once we've entered our language here, it's asking for the root password, which I will set. And it's asking for me to confirm the partitioning layout. For right now, I'm just going to select the one hard disk on this VM and set it up for automatic configuration. As you'll see, we'll have to edit that as we go. So at this point, I could click begin installation, and the installation would start as is. Or I could set more options, obviously. But for this demonstration, I'm going to click on security policy here, and you'll see there's a list of different security policies that we can select. We can also add content from somewhere else right here, but I'm going back to the default content. You can bring in your own SCAP file to support a custom spec. As you can see here, we have ANSI, we have CIS, we have NIST 800, and there's a bunch of other security profiles here: HIPAA, Australian Cybersecurity Center, PCI DSS, DISA. There are several standards that you can specify at install time. So our target for right now is the CIS RHEL8 Benchmark for server level 2. I'm selecting that, and in the bottom box here it will go through your currently selected install options and tell you what would need to change. The entries with a light bulb can just be changed automatically as part of the policy, but you'll see some have this red sign here. This indicates that there's a misconfiguration, and I'll go back and show you from the main menu of the installer what that looks like. It says here there's a misconfiguration detected, and if I click back into that, you'll see here that we need to create certain file systems as their own partition. That's not something it can do automatically, so it's asking us to do it instead. So let me go into the partitioning, which I said we'd have to return to here. And instead of automatic, I'm going to click custom, and I'll tell it to start by creating partitions automatically. And you'll see it takes up most of the disk. There's less than a meg left here, but I'm going to change this size to give us room to add some more partitions. So let's make home 5 gig. We'll make root 10 gig. And as you can see, that gives us a little more space to work with. That gives us another, that didn't take. One moment. So now we have another 35 gigs to work with on the install, and since this is just a demo, we don't have to worry much about how that space is laid out, just as long as we can get through the install. So I'm making var 5 gigs. I will add var temp, another 5 gigs, var log, 5 gigs, var log audit, 5 gigs, and I believe temp was the other mount point I needed to add. Okay, so I've added those 5 mount points. Let me click done here and see if we have any warnings. Okay, it's asking me to confirm what we have here. When we go back to the main menu, there are still warnings in security policy, but you'll see now that the mount warnings have gone away. And if I scroll down here, our other warning is that we've selected to add X11, which is our graphical interface for Linux, which is not supposed to be set according to the CIS benchmark. And again, this isn't something that it can resolve automatically. So if I go to software selection here, I'm going to change this from server with GUI to just server. Click done. And you'll see now security policy says everything is okay. So we are all set to begin our installation. And you'll see here there's some stuff about OpenSCAP from the beginning, but other than that, this just looks like a standard install and there's nothing else to really show here. So I'm going to stop the video at this point and show you what can be done on existing systems. So this is a Red Hat Enterprise Linux 8.5 install that I've done without applying a security policy. And the only changes I've made here, I accepted the default partitioning without the special partitions required by the CIS benchmark, but I did install Apache and configure it through the firewall, and you'll see why during the demo. And I also gave it a network identity and subscribed it to the Red Hat network so that we could install a couple of other packages. So I'm ready to begin applying the CIS benchmark on this new server. And first what we'll do is we will install a couple of packages related to OpenSCAP. There's openscap-scanner, openscap-utils, and scap-security-guide, and as you'll see, this will pull in a lot of extra dependencies. We're installing a total of 74 packages altogether just to do this OpenSCAP work. So the first package that we installed, the openscap-scanner, is actually the scanning engine that will audit and remediate the server based on our SCAP rules. That has to be installed on the server that you're auditing through OpenSCAP. The scap-security-guide is the actual content of the SCAP, the same as what we saw during the Red Hat installer, that PCI DSS and HIPAA and CIS benchmarks and all those other pieces are the content that defines those is installed by the scap-security-guide package. And the openscap-utils package is not strictly required as far as I know in this situation. But what I will mention is you can run a SCAP audit and generate a remediation remotely from another server over SSH. And the openscap-utils contains the extra executable you need to do that. Openscap-utils would be installed on the server, initiating the OpenSCAP review and also the SCAP security guide or whatever content you have for your benchmark is has to be present on the server that's initiating the scan. On the host that's actually performing the scan, all you need is openscap-scanner. So openscap-utils provides the oscap SSH extra, and it will transfer your SCAP file containing your standards from the initiating system to the client system that's going to be scanned. So you don't even need the SCAP security guide or the openscap-utils installed on just a client system if you're going to centralize your scan. So we're almost done with our package install here. I should get my prompt back in just a moment. And I'm going to show you the contents of this directory: user share XML scap SSG content. This is where the SCAP security guide package stores its content, and you can see that there's SCAP security guides for Firefox, JRE, Java Runtime Environment, and then RHEL 6, RHEL 7, and RHEL 8 here. Specifically, this is a RHEL8 server, so we're going to use the RHEL8 files that are over on this right-hand column. And the DS or data stream file contains all of the same standards that you saw during the install. So the way that we can look at what's in this data stream file, first of all, I'm going to create a shell variable SSG, and this stands for scap-security-guide in my mind. This isn't required by any of the tools, but it's just a convenience thing because I am going to end up typing the name of this file over and over again, and it's just easier to refer to it from a variable. So this is this file right here that we're targeting with this variable. And now that I have that, in order to look into the SCAP file and see what's contained within it, we run openscap-info and then the name of the file. And I'll pipe that through more here. You can see that it's this data stream, which is what we were talking about before. This is part of the SCAP standard that enables you to put a bunch of different pieces into one file. The data stream, when taken apart, shows several profiles, and this is similar to what we saw in the installer menu. One of them that we have here that we're going to target is the CIS RHEL8 Benchmark for Level 2 server. And that's just referred to here as profile CIS. All we need is this CIS part at the end. That would be CIS workstation 1.2 for that profile, or E8 for this profile down here, for example. So all we need to do to refer to this profile is just use CIS right here. And I'm going to do that now. I'm going to repeat the previous command, openscap-info, but this time I'm going to give it a specific profile to look at. And again, I'll give it the name of the SCAP file. So once we do that, oscap-info profile CIS and the SCAP file. Now it's showing us detail on this specific profile, and it will show you the standard that all these rules are taken from, including here we have the Center for Internet Security produced this. This is the document, version 101. This is the date that it was released. So all the detailed metadata about what it is we're applying. Now, to actually perform the application, there are two steps necessary. The first one is we need to do an eval, and that is our audit that determines with a pass-fail basis what rules we do comply with and what we don't. So again, we'll use the openscap command, and we're going to use xccdf, and this stands for Extensible Configuration Checklist Description Format. That word salad means this is a checklist of items that we're going to audit, in this case the CIS benchmark. So I'm going to give it xccdf eval and give it the profile CIS, give it the result. I'm going to create a results file in results.xml, and I'm going to create a report, and actually I'll call this results.1.xml, and I'm going to generate a report called report1.html. You could perform just one of these, but I'm going to do both of them in one command here. The results file is used by a later step in the process, and the report file enables us to get a human readable report on what items passed and failed. And again, we give it the name of the SCAP file that we're targeting. So this is going to take a while to complete, but I'll show you the beginning of the process here, and you can see scrolling very quickly up the screen we have each rule being listed along with the identifier, a CCE identifier, and the result, pass or fail. And these are going to take a little while to run, so let me pause it here and I will start the video recording again when it finishes. Okay, so now we've finished, and that didn't actually take much longer than I was still talking. So I have now a results1 and a report1 file. This is why I installed Apache on the server, because if I go to my web browser window, this is just the greeting page by default for the Red Hat server, and I'm going to select report1.html. And this is the report we just generated. This is the listing of all the rules that we passed. You see there's 116 that passed and 132 that failed. It shows you the relative severity of each of these. There's only 2 criticals here, 114 medium. And this is an interactive document in that we can actually take out the rules that passed, we can take out the informational items, we can fold things up and expand them out to see details. As you can see here, this is our old friend, the file systems on different partitions that are fails because I just selected the default disk layout. Now if I click on any one of these rules, it will show me detail, including links to some of the sources and references to more information about those rules and how to remediate them. And it even shows you a remediation snippet here that can be used in Anaconda, the installer, create a separate partition called var log. So this gives us the kind of detail that we're looking for in a typical compliance report. As you can see, there's a lot of findings here. So we're going to remediate those now. And the way that we do that, let me switch back to my shell window here, is we use this results file to generate a fix file. So starting from the previous command, openscap xccdf, instead of using eval, this time I'm going to use generate fix. And again, I give it the profile name, CIS. This time I give it a fix type, and I'll show you both methods. We're only going to use one. But if I say fix type Ansible, it's actually going to output an Ansible playbook that will contain all the items we need to remediate the file, or remediate the server with the SCAP file. So I'm saying fix type Ansible here, and I'm saying I want my output file to be remediations.yml, which is the type of file that we'll use for an Ansible playbook. And we want to take our fixes from results.xml. Oh, I had it named as results1, my mistake. And no output came back, but we see there's now a remediations.yml file in here, and if I look at that briefly, we'll see that it is an Ansible playbook, and it defines a bunch of variables at the top here, but once we get into the meat of it, it's showing for each task the name of the task, what item it's related to, and it's actually tagged the items in that Ansible playbook so that you can run just some of them selectively. But if we were to run Ansible playbook and had Ansible installed on this server, remediations.yml, this would perform all the remediations in that playbook. Now let me bring back that previous command, and instead of using fix type Ansible, I'll use fix type bash, and I'll change the output file to remediations.sh. And again, no output, but there's a new file in the directory. And if we look at that new file, we'll see that again, and this time in bash shell script format, we have a file that contains all the remediations needed to fix this server. And here's the first fix, for example. So, it's yum installing a package. Now this time we're actually going to go ahead and run this file. So I'll type remediations.sh, hit enter, and there's a lot of output. It does show you the output as it's performing each remediation, but you can see here we have 255 rules to apply, but it's ripping through them fairly quickly. There will be a couple that take a while to execute. So let me pause the video until that's ready. Okay, so the remediation just completed, and we haven't added any additional files here, but before I do anything else, I'm going to recall my eval command that I ran up here to generate this initial report. And I will create a second results file and a second report file here post remediation. Okay, so that second report post remediation just finished, and you'll see now we have a report 2 and a results 2 file here. So we'll switch over to our web browser, and where we had report 1 listed before, we'll change to report 2. Now we're actually having some trouble loading, and part of the reason for that is the remediations we just applied. They apparently either shut down Apache or turned off the firewall port that was open for port 80 to hit it with our web browser. So let me take a look at that real quick. I'm going to do a system control status, if I can type, httpd, and you can see here it's masked. So we need to unmask that. And we will start httpd, and now let's see if we can get through or if there is still a firewall rule holding it up. Okay, I think we're fine. Let me transition back to that window. And again, I'll change the URL here to report 2. And now you can see that we have 235 rules that passed and 13 that failed. Only 1 high vulnerability and 8 medium rather than the 2 high that we had before. And those, again, are things that we cannot easily change ourselves through an automated rule set. We couldn't create separate partitions and move around file systems on an automatic basis. It also didn't want to set a bootloader password and lock us out of the server. It didn't want to set a default firewall zone and lock us out of the server that way. So it tries not to do anything too dangerous, but as you can see, we resolved a huge number of changes and made the system far more compliant. And really, file system options and partitions and things like that should be handled at install time. So it's done most of the things that we want it to do. And that is the conclusion of how to use OpenSCAP to apply the CIS benchmark automatically using a vendor tool. Thanks for watching.